Welcome! In this session, we will predict our dependent variable on our testing dataset using the model that we just created in the previous session. So we are here in R, ready to make the prediction. We will create the variable, prediction equals to the function compute, which is part of the neural net package. And this function has two arguments. The first one will be the name of the model that we just created, model 1, and the second one will be the dataset in which we want to apply this model to make the prediction, which will be the dataset testing. I press enter and we just created the prediction. Now let's create the default flag vector with the real data. So we are going to create the variable testing.original. I have just created this in a previous session that I didn't record. And we are going to use the credit cards dataset. And from this original dataset, we are going to get only the observations that were not part of partition. So the ones that were in our testing dataset, if we could say it like that. So we are going to get this partition. We're going to get all the rows that were not on partitions and comma, and as I don't write anything, I'm going to get all the columns. I press enter. And from this testing original, we're going to extract the dependent variable. So we're going to get the real data. The real data, real defaulter, equals to testing.original, and I write the sign of dollar, and I'm going to get the dependent variable. Why I'm not using, for example, that's a very valid question. Why I'm not using the testing dataset? Because at least in this case, both are normalized. They are both between 1 and 0. But in the general case, one of them, the testing, will be normalized, and I want to get the real data. So the data that was not normalized, the normalized or unnormalized data. So that's what I'm using, the original dataset. Now let's extract the normalized prediction vector. We are going to create the variable pred defaulter dot norm equals to prediction and the sign of dollar net result. So I'm getting now the normalized prediction vector. And as I already said, in this particular case, the data that we are getting is already denormalized because it was between 0 and 1. So we are going to do the following step to illustrate the general case. In this case, it doesn't make sense because our data was between 0 and 1. But in the original, in the general case, you will always have to denormalize the data because you have been working with data between 0 and 1, and now you want to compare it with the real data that is not between 0 and 1, at least in the general case. So we are going to apply the inverse formula that we use to normalize data. We're going to create the variable. Let me clean the screen. We're going to create the variable pred.defaulter equals to, shift enter, pred defaulter normalized, just the variable that we just created, and we're going to multiply it by the difference of the range of the real defaulter. And to these results, we are going to add the minimum of the real defaulter. And with this, we are unnormalized or denormalized the data. And now we will create a data frame containing the predicted and real defaulter flag variable. So we are going to create the variable defaulter flag equals to a data frame that will contain two columns. The first column, the real data, real defaulter, and in the second column, the predicted data. prediction equals to pred.defaulter. I press enter and we just created a data frame. We can look at it if you want. View defaulter flag. I press enter. And you can see here the two columns, the first one with the real data and the second one with the predicted data. As you can see in the first one there are zeros and ones, the real data, and in the second one there is a probability of default. So our model is computing a probability of default. We have to set a cutoff point and then also set which one of them are going to be defaulters according to our prediction. And that's something that we are going to do in the next session, and we will do this in Excel. We will export this data frame as a CSV file to set up the cutoff point in Excel. This is something we could do in R, but it is more illustrative to do it in Excel manually and step by step. So I'm going to create a CSV file with the data frame that we just created. Write.csv as argument the name of the variable that we want to export, in this case is defaulter flag, and in the second argument will be the name of the CSV file, defaulter flag 1.csv. I press enter, and with this I have created a CSV file that I can manipulate in Excel to set up the cutoff point. Thanks for watching.